Let's go. So we have another problem here. Let's look at it. 9 times 4 to the power x minus 9 to the power x plus 1 over 3 to the power x plus 1 minus 3 times 2 to the power x. We have a minus sign at the top, minus sign at the bottom, which means we have two terms at the top, two terms at the bottom. And if we look at the current situation as it stands, basically we have a 9 here. And you know what? Let's just change it into its prime base. All right. 4 is written as 2 to the power 2. The 2 and the x get multiplied. Minus 3 to the power 2. And obviously that would be x plus 1. So we will distribute that 2 into x and into 1. Let's go down. 3 to the power x plus 1 minus 3 times 2 to the power x. Moving right along the very next step. 3 to the power 2. 3, that's 2 to the power 2x already. Minus, we distribute the 2, this becomes 3 to the power 2x, 2 times x, and then 2 times 1 becomes 2 there. All right, we are going to go ahead and split this obviously as we go along. All right, maybe we could have done that in the previous step, but I just want to show you step by step how I have been able to get to where I do get to. Let's just avoid finding ourselves in a situation where we find out, right, we change the 2 to 3. That happens because of silly mistakes, or we omit to write the 2 and we write x. Just make sure that when you write things down, you still write them out the way that you had originally written them, so that you don't miss out on anything. Now, 3 to the power x plus 1, we split that. That's 3 to the power x and 3 to the power 1 minus 3 times 2 to the power x. So everything now has officially been split. All right, I changed all to prime bases, 9 and everything. I then split everything, used the distribution law here after writing 9 as 3 to the power 2, put the bracket so that I can distribute the x to both the 2 to the x and the 2 to the 1. That's very important because sometimes we forget to take this 2 and distribute it to the last term. It's very important because the law requires us to distribute the 2 to both terms outside the bracket. Then from here now, what can we see? What can we see? Here we can see that the common factor is actually 3 to the power 2. The base variables basically have no common. So basically we take out 3 to the power 2 in the numerator. That leaves us with 2 to the power 2x minus 3 to the power 2x. Hopefully that makes that very clear. Over. Look at the denominator. Once again, the common factor is 3. It's not 3 to the power x because the bases are different. So we take out 3 and then we are left with, in brackets, 3 to the power x minus 2 to the power x. Now something very interesting to note here is that if we look at what's inside the bracket, we can't really cancel what we have there. But there's something we can do inside here because we see that there's a type of factorization that can be applied. Why? 2 to the power 2x is a perfect square. 3 to the power 2x is also a perfect square. Why do I say so? 2 to the power 2x can actually be written as 2 to the power x times 2 to the power x. Do you see this? 2 to the power 2x can be written as 2 to the power x times 2 to the power x. 3 to the power 2x can also be written as 3 to the power x times 3 to the power x. Remember, when the bases are the same, what do we do to the exponents? We add them. So 3 to the power x, if we were to add these two, we get this 2x back. We keep the base and we add the exponents to get 3 to the power 2x. Hence, I was saying 2 to the power 2x is a perfect square and 3 to the power 2x is a perfect square. And what do you see here? A difference of what? Of two perfect squares. So first and foremost, 3 to the power 2 divided by 3, we can actually cancel that. We know that 3 to the power 2 minus 1 is what we would basically do if we apply law number 1 of exponents. 3 to the power 2 minus the exponent 1. Okay. And then this is what we'll do. We'll factorize this. Open two brackets. This is 2 to the power x times 2 to the power x, which will give me back 2 to the power 2x. Then I have plus and minus, because this is difference of two squares. 3 to the power x this side and 3 to the power x on this side. Then on the denominator, I have 3 to the power x, of course, minus 2 to the power x. Okay. All right. Then, where does that actually then lead me to? Okay. It leads me to the following place. 3 to the power 2 minus 1, that gives me 3 into. Now, look at this. If we want to change the order of what we have here, right? So that these two are the same, because these brackets, we can cancel them, but we can't in the moment, because 2 to the power x minus 3 to the power x is not the same thing as 3 to the power x minus 2 to the power x. So what we'd have to do is we would have to do the following if we want to affect a cancellation. I'm going to explain just now. We take out a negative sign. This is called the sign change rule. We take out a negative sign, then we write 2 to the power x as the first term. We write 3 to the power x as the last term, so that these two brackets are now essentially the same. You can only do that when there's a minus for two brackets that could be similar, but it's just that the order is different. Okay, we take out the negative sign. Then we change the order of the terms. 2 to the power x is written first and 3 to the power x is written second, whereas it was different originally in this denominator expression. So let's check this out. If you take the negative and you distribute it back to the 2x, don't you get this negative sign back? Yes, you do. If you take this negative sign and you distribute it back to the negative 3, don't you get the positive 3 back? Yes, you do. So when we take out the negative sign, it changes nothing fundamentally. But we then are allowed to cancel these two, which leaves us with an answer of positive divided by negative gives us a negative 3 brackets 2 to the power x plus 3 to the power x. Okay, and then if you're someone else, some people would even go ahead, instead of leaving it like this, would distribute the negative 3 so that you get negative 3 times 2 to the power x minus 3 times 3 to the power x, and then they leave it like this. That would be perfectly fine. That's okay. All right, I hope this question is good without any